हेलो बच्चों, let's read the question. The question says find the number of values of x satisfying the relation alpha 1 cube. This is the product of I equal to 2 to n x minus alpha I divided by I equal to 2 to n product alpha 1 minus alpha j plus sigma j equal to 2 to n, then again product of terms from I equal to 1 to j minus 1 alpha minus ij, and product of I equal to j plus 1 to n x minus alpha j divided by product of j I equal to 1 to j minus 1 alpha j minus alpha I and I equal to j plus 1 to the power n and alpha j minus alpha I times alpha 1 cube plus again product of I equal to 1 to n minus 1 alpha x minus alpha 1 divided by product of I equal to 1 to n minus 1 alpha n minus alpha I and alpha n cube minus x cube equal to 0, where n is greater than or equal to 5. Clear? So here we are going to use a very simplest formula that we will be putting the values of all these first, and then after that we will be trying to get the actual result, that whatever is given there. So first of all, let us go through the key concept. Key concept this is a symbol of product, and if I am writing I equal to 1 to 10 for example, so and x minus alpha I, so it means that we have to start from x minus alpha 1 and then x minus alpha 2, and it will go up to x minus alpha 10. That's it. And that means product. We have to take the product of all this. So using this concept, I am going to look at the question, and then I will try to find out whatever is being asked in the question. So given, that's a very big statement. So anyway, given alpha 1 cube and then product I equal to 2 to n x minus alpha I divided by I equal to 2 to n alpha 1 minus alpha I, and then this is the first term, and second term I am going to write with the sigma j equal to 2 to n minus 1, and then again we are writing like this, that is let me start with the curly bracket as well. So it has been given product I equal to 1 to j minus 1 x minus alpha I, then second one product of I is equal to j plus 1 to n x minus alpha I divided by again product of I equal to 1 to j minus 1 and alpha j minus alpha I, and then again there is a product of I equal to j plus 1 and 2n, and then it is alpha j minus alpha I, right? And now it is closing here and times it is alpha j cube and then this final bracket. And the last term is given as it is given product of n minus 1, sorry, 1 to n minus 1. Just let me clear it. Product of I equal to 1 to n minus 1 x minus alpha I divided by I equal to 1 to n minus 1 alpha n minus alpha I, and this whole thing divided by alpha n cube minus x cube is equal to 0. So first of all, you see here that it will go from x minus x2 to x minus x1 product. And at the denominator also it will go from alpha 1 minus alpha 2, alpha 1 minus alpha 3 and so on. It will go up to alpha n. Now see here in this one. What is here? This is a sigma they are saying. So if here you are finding it is also I and it is also I. So it is starting from 1 to j minus 1 and then it is starting from j plus 1 to n. That means it is in continuation. Right? After j minus 1 I will writing here and after that we will be coming to this place. Right? And in the same manner here I equal to 1 to j minus 1 and here j plus 1 to n. That means they both will be approximately same and they will be coming like that x minus alpha 1, x minus alpha 2 and so on x minus alpha n. If we will be looking here because it is coming from here to here. Right? And here also it will be coming like this only, that alpha 2 minus alpha 1, alpha 2 minus alpha 2 minus alpha 1 because it is starting from 1 to j minus 1 and this like that. So we will be taking first as alpha 2 and alpha 2 minus alpha 1, alpha 2 minus alpha 3 and it will carry on that alpha 2 minus alpha n and so on, then alpha j cube, that will be alpha 2. Right? So one we have to adjust here. That will start from I equal to 2 to that because here it is given j equal to 2. We have to sum up. So I will be writing few of the terms, not all the terms, and plus 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 and then alpha 2 cube because j is starting from the 2, so I will be taking 2. Right? And I will be starting here also from x minus alpha 1 and denominator will be starting from alpha 2 minus alpha 1, alpha 2 minus alpha 3 and so on. And the last term again x minus alpha 1, x minus alpha 2 and x minus alpha n, and in the denominator I is only changing, so alpha n minus alpha 1, alpha n minus alpha 2 and so on. We will be keep on going on and then we are writing alpha n to the power 3 minus x to the power 3 equal to 0. So we will be looking into that what kind of polynomial it is going to be formed. And after that we will see that how we can move forward. So I am changing the page and moving, changing the ink as well. So I am writing the that how we can expand those all. So that will be alpha 1 cube and it will be giving you x minus alpha 2, x minus alpha 3. It will go up to x minus alpha n divided by alpha 1 minus alpha 2 first term. Second term will be alpha 1 minus alpha 3 and so on. It will be last term then alpha 1 minus alpha n plus. Then again you will be getting there x minus alpha 1 It will start from 1, x minus alpha 2, and it will be going on x minus alpha n divided by, you will be getting near in the down that alpha 2 minus alpha 1, then alpha 2 minus alpha 3, right? And so on, it will go up to alpha 2 minus alpha n. So this will be the first, and that will be given as alpha 2 to the power q. Then again we will be doing the same thing, and we will be starting from here, because here it is a sigma. So such type of terms we will be keep on writing, and then I will be keeping closing. And the last term which will be coming, that will be x minus alpha 1 and x minus alpha 2 up to x minus alpha I. Sorry, x minus alpha. This is x minus. So let me clear it first. Right. So last term जो आएगा इसमें x minus alpha n, और डिनोमिनेटर में जो आने वाला है वो क्या आने वाला है, वो n से स्टार्ट होगा, तो अल्फा n माइनस अल्फा 1, देन अल्फा n माइनस अल्फा 2, और ये कहां तक चला जाएगा, ये जाएगा अल्फा n माइनस अल्फा n माइनस, अंडरस्टूड? एंड आफ्टर दैट व्हाट इज गिवन, after that it is given here, I will be writing, it will go to this side, that is alpha n cube, sorry, alpha n in the superscript नीचे आएगा, alpha n cube minus x cube is equal to 0. This thing will go to that. So this we are getting here. So what are we finding? That this is a polynomial in degree n. So this is a, we will be writing that this is a polynomial. This is a polynomial. Is the polynomial of degree n minus 1, right? So when it is a degree polynomial, so it will be having factors then, am I right? It will be having the factors. So what factors it will have? So if we are putting if I am putting x equal to alpha 1, so what will I get? Tell me. Alpha 2, and so on up to alpha n. If I am putting on this polynomial, in this polynomial, so what we will get? I will be getting alpha 1 cube, sorry, alpha 1 cube, it is already here, प्लस 0, यहाँ पे ये x माइनस अल्फा 1 है, यहाँ पर भी x माइनस अल्फा 1 है, तो ये सब 0 0 हो जाएंगे, प्लस 0 और माइनस यहाँ पे क्या आ जाएगा, अल्फा 1 क्यूब, यहाँ पर आ जाएगा अल्फा 1 क्यूब, तो ये 0 हो गया, 0 0 ये कैंसिल हो गया, और दूसरे अगर अल्फा 2 रख रहा हूं तो क्या आएगा, यहाँ पे आ जाएगा 0 प्लस अल्फा 2 क्यूब प्लस 0 माइनस अल्फा 2 क्यूब, अगेन 0, और अल्फा 3 रखूंगा तो क्या आएगा, इसी तरह से अल्फा 3 रख कर क्या आएगा, और जब अल्फा n रखूंगा तो क्या आएगा, अल्फा एन रखूंगा तो लास्ट वाला अल्फा एन बच जाएगा और उससे पहले भी वो आ जाएगा. सो 0 अल्फा एन क्यूब माइनस अल्फा एन क्यूब. राइट, ये तो दिया ही हुआ यहाँ पे. तो यहाँ पे अगेन ये कटिंग डाउन हो रहा है. इज इट क्लियर? So alpha 1, alpha 2, alpha n, they are satisfying the polynomial here. So I am changing the page again. So here I am changing the page. Okay. What happened? Yeah. So it means alpha x equal to alpha 1, alpha 2 up to alpha n satisfy the polynomial. Satisfy the polynomial of degree n minus 1. Am I right? It means n minus 1 degree polynomial, n minus 1 degree polynomial may have maximum n minus 1 roots. Am I right? But what are we finding? But here it is found that n values of x are satisfying. N values of x are satisfying. That means it is more than that. So what can we say? So we can say that any number of values of any value of x can satisfy the polynomial, can satisfy the given expression. Rather, you may write like this: can satisfy the given expression. What does it mean? Any value. I am going to change the ink. Any value I am saying. What does it mean? It means that number of roots or the number of values of x or roots of the polynomial, roots of the given polynomial number of values of x or roots of are infinite. So this is only they were asking that how many values of the x will be satisfying that given equation, and here we have found that a number of values of x, or we can say that these are the roots also, are infinite. So here we have used the key concept, that's why it's a very general, that this symbol is using for the product of the terms in continuation. Likewise, I equal to 1 to I equal to 10, x minus alpha I can be written as x minus alpha I, x minus alpha 2 up x minus alpha 10. And we are getting that number of values of x satisfying the given polynomial are infinite. Hope you understand it well. Best of luck. Thank you.